Hello dear students, welcome you all once again to the expected to be a wonderful session on NEET preparation in the coming 10 days. So these 10 days of the sessions, we are already into our third day of the discussion. We are going to learn the concepts, fundamentals, the basics through the solving of the questions. As we could see for the last 2 days, we have been working out on numerous questions, wide variety of solutions and discussing the theory as well. And glad to see that the students are actively participating in the questionnaires. That means when we are striking the slide with some questions, we could see randomly the students are giving fabulous answers. And it's good to see that you are engaging this session pretty good and anticipating the same from you in the coming time as well. So without wasting much of your time, let's quickly get into the session by discussing some more questions of that kind which were asked previously in the past NEET examinations. The point is, we don't say that these questions only would be asked. As you know that the national level entrance examination have a habit of not repeating the questions very frequently. However, the questions can be what you call repetitive in the concepts or the fundamentals. So we would urge you to stay tuned and try to solve these questions as much as possible. If you have any doubt related to any topic, do not hesitate to ask me, right, in the form of the comments. I think I am audible, Anish. Yes, now I believe it's okay. All right, even the technical persons have realized that mic is not working and now it is rectified. All right, I was off the screen, that's why. Good evening all of you. Navya, Lily, Anish, glad to see you buddies again. Chalo, let's start the session without wasting the time. You know the timings, isn't it? Please follow the timings, learn the concepts. All right, so I'll see you every day at 4:30 p.m. for this 10 days. Now listen to me, the first question is from chemical kinetics, your favorite, our favorite, Arrhenius theory. If you remember yesterday also we had discussed one very beautiful question about the activation energy, and today the question is about the slope of Arrhenius equation. Let me give you some inputs related to the Arrhenius equation. Listen to me, when you take the Arrhenius equation which is being written as K equal to A e power minus EA by RT. Today we will do little bit variety. We will see where we could commit a mistake, where there is a scope of an error. Alright, Shuklaji. So let's see where we might commit the mistake as well by discussing the concept through the equations. Now listen, when you take Arrhenius equation, you call or you refer this K as the average rate or rate constant. This is the rate which changes exponentially with temperature. You know that temperature rises the rate, alright, and that rise is known as exponential, alright, sudden. Now what is happening here? This K would also represent the number of fruitful collisions that are taking place between the reactant molecules. Number of fruitful collisions. And what does this A represent? Remember that it indicates the total collisions. What I mean to say, that not all collisions lead to the product. You know that, isn't it? Not all collisions lead to the product. Only few which are properly oriented are giving rise to the product known as fruitful collisions. Alright. So K represents the fruitful collisions, A represents the total collisions. Therefore the ratio, always remember this part is missing so far. Never the question is asked on this, so stay tuned, this is important. When you write the ratio of K and A, what does it represent? It represents the fraction of the molecule. You can see it's a fraction because this is fruitful collisions, effective collisions, and this is total collisions. So the ratio would indicate the fraction of the molecules crossing the energy barrier. What is that energy barrier? You all have studied. What will happen there when you are studying the energy graph? What will happen there? You know that this is the activation energy and this is the energy barrier. So what fraction of the molecules are crossing the energy barrier is calculated by using this ratio, which is referred as Boltzmann factor. So this is the area which is still untouched. So please be careful this year, aspirants. This is one important zone from where the questions are asked or may be asked. Yeah, ठीक है? Anish, can you hear me? All right, Rasagna. Yes, I will provide you more questions, Rasagna. Okay, now this is very important. Now coming on to this question, what mistake we might commit. So I will erase the ink here. Now let me write something which is very important. You can see when I am writing the Nernst equation, when I am applying the logarithm on both the sides, because there is an exponential term, it will become anti-log when it comes this side, equal to natural logarithm of a into b is natural logarithm of a plus natural logarithm of b. You have studied this integrated form. So when you are writing it, natural logarithm of k equal to natural logarithm of a, you know that this gets cancelled and this come over here, minus Ea by r into 1 by t. So this is the expression which has to be compared with the data which is given to us. You can see that this is y, this is the intercept, minus this whole factor is the slope into this is x coordinate. So here when you are plotting the graph between the y coordinate being natural logarithm of k, y equal to, right, c minus mx, you know that the x coordinate is 1 by t, you will get a straight line with negative slope. You guys can see that the slope value is equal to what? Minus Ea by r. Sir, what could be the mistake that I might commit in this question, isn't it, Rasagna? What could be the mistake? That mistake would be usually when you write base e or base 10 logarithm. You must check what is the data which is given. You can see it is between natural logarithm of k versus 1 by t. At times, you may be asked the question related to base 10 logarithm versus 1 by t, then in that case slope will not be minus Ea by r, rather in that case when you are writing here log of k, the slope will be minus Ea by 2.303 r. So please make sure that you observe the given data thoroughly, properly, focusedly. It should be either log base 10, then in that case slope is this, base e, then slope is this. You can see in our question base e is mentioned. Natural logarithm means the base would be e. Okay, then in that case you need to write the slope value as minus Ea by r, activation energy. So this is one thing that we need to be careful. That's all. Remaining all you guys can pretty well work out. Is equal to the slope is given as 5 into 10 to the power 3. Now, what are the value of r that I will substitute depends upon the option that are given. You can see the options are in kilojoule per mole. Then in that case r value would be, Anish bete, what you would substitute? 5 into 10 power 3 into 8.3 into 10 to the power. Alright, how much you are going to substitute? Kilojoule, right? Isn't it? So this is how you are going to solve this question. I hope you understood. Alright, shall I move on to the next question? Okay, A, ठीक है, बिल्कुल सही. You guys can see. Okay, Nandu, come on, concentrate. Please tell me the name of this compound. Come on, everybody. IUPAC nomenclature is an easy chapter. Navya, come on, speak out. What's your answer on this? Anish Vete, come on, I am waiting for your answer. What could be the answer here and what is the criteria? Nandu, come on, focus on this. You are not here to read the comment section, you are here to learn the sessions, isn't it? Now, Anish says the right answer is C. What about the others? Navya said D. Come on, I am waiting for your answer, Nandu. Come on, speak out. D. Everybody said D. Now, let me clarify one thing for you here. Lily also said C. Please listen to me, buddies. Come on, listen to me. This is very important. You guys are making silly mistakes. Nandu, you said C. Just let's check. See, first of all, why C and D are ruled out? You have forgot that the C and the D options have the double bond given least preference. You can see double bond is given third position. Do you accept that? You should give the functional group the first position, isn't it? Those who have said the answer as D daily, or most of the students are repeatedly saying C, I don't understand. Have you understood? This is the mistake what we might tend to commit, right? You know, functional group is given top priority, first preference. So how could it be third? So how could you say C or D? Then you have these two options, you guys can see. Sounding the same, named the same, isn't it? 1-methyl, 6-ethyl, 6-ethyl, 1-methyl, cyclohexene. You know, when there is a tie, yes, you are right. When there is a tie between the numbers, you must take the alphabetical order, isn't it? You must take the alphabetical order into consideration, and what comes first? Obviously, E comes first. So, what should be the right answer, buddies? Alright, so when you number it, it goes like this. Alright, 1. After that, we get a doubt. Sir, I anyways label this as 1. Can I go this side? If I go this side, I will get second position for the ethyl. So, why am I writing the sixth position for ethyl? For the reason that when you are numbering the alkene in a ring at first position, you must cover all the carbons of alkene. That means not here, rather in order to cover all the carbon atoms of the alkene, you must go this side, buddies. You must cover both the carbons of an alkene in the ring. You cannot go just like this, what you call leaving this second carbon atom, which is also part of the ring, which is an alkene. So don't do that mistake. You are fortunate that the options are not confusing. Options are very straight, isn't it? Are you understanding? So please concentrate. Okay. So now this should be the pattern of numbering, and then what's the name of the compound alphabetically? What comes first? 6-ethyl, 1-methyl, cyclohexene. Need not mention 1, but option is there, so we are mentioning. So you guys got it right. Nandita, brilliant. Manish, that's good. So answer is B, Bombay, isn't it? Now tropone, we have discussed. If you remember, go and watch your older videos. Yesterday and day before yesterday we have discussed aromatic compounds, right? Aromatic compounds can be divided into benzenoid and non-benzenoid. Benzenoid means benzene would be certainly present. Like you have benzene, naphthalene, anthracene are called benzenoid systems. Which does not have benzene, like you have cyclopropenium ion, cyclopentadienyl anion. They are catering the needs of or catering the conditions of aromaticity, but they are not having benzene. Non-benzenoid, they don't have benzene. Fantastic, Aman. They don't have benzene. Now we can see this compound tropone, it's a ketone. That's why one comes at the end. This compound doesn't look to be what you call aromatic unless these pi electrons are shifted upwards. Now what will happen here when the pi electrons are shifted upwards? You can see this forms as dipolar ion, and you guys can see in the ring. Come on, check out in the ring what's happening. Inside the ring, check out what's happening. there are 3 pi bonds, that is 6 pi electrons are involved in delocalization in a cyclic delocalization of 6 pi electrons. This is actually the condition which is required for what? Aromaticity. So, this is non-benzenoid aromatic system, otherwise this is called tropylium ion. Alright, ठीक है, I request you to concentrate here. Tropylium ion, Hakel rule. चलो खैर हकला नहीं बोला. Alright, yes, this is a kind of resonance body that occurs inside the ring. Anish, I think you know this, right? Resonance occurring in the ring. Aromaticity के वास्ते resonance should take place inside the ring. Outside resonance is not valid for what you call aromaticity. Please understand this. Okay. Chalo, next question is about acidic strength. Alright. pKa value, it's a statement, assertion reason based question. Let's read the statement. pKa value of phenol is 10, while that of ethanol is something like 15.9. Alright. So, what is pKa? pKa is a measure to predict the acidic strength. Alright. Order. If you have got phenol and ethyl alcohol, you guys tell me which one is more acidic. We have studied several times that which one is more acidic, buddies? Which one is more acidic, phenol or ethyl alcohol? Come on, speak out. Vaishnavi, what's the Anish bete 462 last time? That's a fantastic score. Good job, Nandu. You got 549. Great. Which one is more acidic? Come on, speak out. Aman said phenol. That's a brilliant answer, buddy. Yes, phenol is more acidic. You know the reason why? Because when you pluck out the hydrogen from here, the conjugate base which is obtained is resonance stable. हम जानते हैं, we know this. Phenoxide is resonance stable. Therefore, you say that the acidic strength of phenol is greater. So, whichever is more acidic, remember this, whichever is more acidic will have more Ka. That means your phenol has more what? Ka, acid dissociation constant. Now, what is pKa? pKa is nothing but negative log of Ka. That means if any acid is stronger, it will have more value of Ka. If I substitute Ka here, since there is a minus log negative, the pKa value will become low. That means strong acid has less pKa, and that's what is mentioned there. Phenol is a strong acid, hence its pKa is lesser than ethyl alcohol. That seems to be correct. But in the reasoning, you can see ethanol is stronger than phenol. This is not acceptable, isn't it, Anish? So, A is assertion looks to be correct, reason is not correct. What happened to you, buddy? Yes. Doraemon, Jai Baba. Have you understood? Huh? A perfect blend of Indian comic as well as the foreign comic. I hope you understood. Chalo. Let's see the next. Alright. Choose the correct reaction. Let's choose the correct reaction, Mayank. You can see that if you take this reaction, what do you call this reaction as? Can anyone tell me what is this reaction called as? Very popular reaction, isn't it? What do you call that? Come on, speak out. Vaishnavi. This is called as Hoffman hypobromide or degradation reaction, right? Name itself indicate degradation. In the yes, bromamide or aman is super fast, right? Bromamide also, you also call it as high Hoffman bromamide reaction or degradation. Degradation itself means there is a decrease in the number of carbon atoms by 1 unit. So what will happen when you carry out this reaction? The product would be CH3CH2 NH2. So there is no extra CH2 that would be present. So this is not correct. And you can see when you are carrying out the reaction of bromine with UV light, free radicals are formed. Good, excellent. Free radicals are formed, right? Bromine radical will carry out what? Allylic substitution, not addition, right? If you want to add bromine in bromine onto alkene, what should be the medium? CCl4. Yes, free radical substitution. So the product should be hydrogen replaced by the bromine. That's brilliant. So this is also not correct. Now look at sodium borohydride in the next option. Sodium borohydride reduces only the polar pi bonds. This reduces only the carbon oxygen double bond, but not carbon carbon double bond. Remember, this is reducing only polar. Polar means carbon oxygen, carbon nitrogen, but not non-polar. But over here non-polar reduction is also shown, so this could not be correct. So what is that we are left with is, what is this reaction called as? Very popular, isn't it? Yes, brilliant. Carbylamine test. Good job. Isocyanide test. You know this, right? What will happen there? The primary amine, when reacts with chloroform and KOH, you will be getting isocyanate. Now I would like to ask you one extra question from here. What is the intermediate which is formed in this reaction? Can anyone tell me? Intermediate is what? In carbylamine test. I'm waiting for your answers. I'm asking you what is the intermediate formed in carbylamine reaction? Venkateshwar Rao, Aman, nucleophile, Doraemon, Anish, thoda sa mehnat karo. Come on, speak out. Chalo, let me tell you that also, because we are discussing the subject here. We can't take any chance. Listen to me. The chloroform is this. Now, when you treat chloroform with the KOH, the base is supposed to abstract the acid, that is HCl. When you remove HCl from here, what is that you are going to get? Listen to me, what do you get here? Is called dichlorocarbene. So remember, the intermediate that is formed is dichlorocarbene. Please make a note of this important thing. I told you wide variety of questions can be asked. So the intermediate is, like Aman said it right, brilliant, CCl2. Excellent, buddy. Yes, CCl2 is an electrophile. Shall I ask you one question on this, Anish? Is CCl2 an electrophile or nucleophile? You guys can see that it has a lone pair as well. Can you see that it has a lone pair as well, right? So is it an electrophile or nucleophile? Come on. Like you guys have said, it is electrophile. Why electrophile? Oh, I don't know, what should I call you, Doraemon? Could you please tell me? Electrophile? Yes, brilliant. Yes, fantastic. Someone said nucleophile. Anish said nucleophile, but rest of the people are saying electrophile. Electrophile is the right answer. Yes, brilliant. Brilliant, Doraemon. You are really a magical Doraemon, it seems, right? Yes, you are absolutely correct, buddy. You can see its octet is incomplete. Dichlorocarbene, can you see? Not an exception, Anish. See this reason. You guys can see that it has 2 bond pairs and 1 lone pair. That means it has how many electrons in the valence shell? 6 electrons. Therefore, it is an electrophile. That's brilliant. So that is the reason why it is attacking on the nitrogen, otherwise why would it attack? Isn't it? What an answer, Sarji. sp2 hybridized. Huh? He is giving more information than required. Superb. You must be thankful to the teachers who taught you, buddy. That's so brilliant. Now listen the next, this thing. You see, we have studied in electrochemistry that conductance, I'll write a statement, you guys have to correct me if I am wrong. Conductance increases with dilution. True or false? Come on. Speak out, buddies. Asking you. Conductance increases with dilution. Sahi hai galat? Correct or tappa cheppandi. I'm waiting for your answers, buddies. Yes. All of you agree. Speak out. Conductivity is constant, Anish. Nandu, come on. What's your answer, buddy? Listen now. Conductance has to be divided into specific conductance. Listen to me carefully, buddies. Molar and equivalent conductance. Molar and equivalent conductance. I am dividing the conductance part into specific conductance and molar or equivalent conductance. You know that specific conductance is also referred as conductivity. One and the same. Now with the dilution, that means when you are adding water, molar and equivalent conductance value increases because more number of ions will be formed when you add more water. Oswald dilution law. But like Aman said, the conductivity decreases upon dilution. So assertion is correct. Specific conductivity or specific conductance of electrolytes decreases on dilution is correct. Now why does it decrease depends on the definition that you give. Conductivity is the conductance of 1 ml of solution. Now when I am adding water, number of ions present per ml decreases. That means less number of students sitting per bench. Therefore conductance will decrease. So this also looks to be correct, isn't it? On dilution, the number of ions per unit volume decreased, hence the specific conductance decreases upon dilution. So both are correct, and I think this comes, yes, graphics, isn't it? Brilliant. A is the right answer. Come on, no distractions please. Serious sessions and you have got less time to go ahead. Look at this question. Repeatedly this is coming. Yes, Doraemon is always right. He has that magical powers, isn't it? Listen now. Delta G naught, that is second law of thermodynamics, equal to minus RT natural logarithm of equilibrium constant. Equilibrium is equal to minus NF E naught, electrochemistry. One equation has the connection of all three chapters, which are very, very important. 2 first year, 2 11th, 1 12th. So this is a question which is frequently seen in most of the exams. So let's not waste it. So let's substitute the values. You can see the equilibrium constant for the cell reaction is 10 to the power 10 and E naught is given as X. This is not so difficult unless you have the clarity regarding the N, and you can see N is also not confusing. It's given as 1 electron. So straight away substitute the values. Alright, so you can put it over there. You better convert this into log base 10. All the students, please make a note that when you are converting log base E into base 10, you have to multiply this by 2.303 into 8.314. Temperature is usually 298 Kelvin. Alright, log 10 to the power 10 because equilibrium constant is given. N is 1, Faraday is 96,500 into E naught value is given as X. So when you are held up in this situation, Aman, alright, what is that you are going to do? You are going to write RT by 2.303 RT by NF. Always remember this value. What is that value? What is 2.303 RT by F will be 0.06. So better you remember this value. What do you all say? Do you agree? Is that clear? Have you understood that particular thing? So it's always good to have that value with you in your mind. Alright, because simplification of this whole sum equation will be difficult for you otherwise. So don't ever try to do any variety, just put this 2.303 RT, T usually 298 by F, that whole value as 0.06. Alright, this whole value, this gone and this also gone. This is 0.06 divided by N, that is equal to 1 into 10 log 10. Log A power B is B log A. So this thing is gone, only 10 will be left, is equal to X, alright, 0.06 or 0.0591 into 10. So 0.591 or 0.6 would be the answer. Look at Vaishnavi, she got the answer. Excellent. Who else have got? Doraemon. Anyways, as usual, Anish, thank you for complimenting that. Anyways, you understood how to write that value. That's very important because frequently you will come across that. So don't miss that, okay? Good job, brilliant. What this reaction is called as? A popular reaction. Using one reagent, reaction is called by some other name. What is this reagent? Yes, that's what we did, Anish. That's what we did. Brilliant. Rosenmund reduction. Yes, Rosenmund reduction, isn't it, Aman? And what that catalyst is called? Catalyst को क्या बोलते हैं? Lindlar catalyst. Brilliant. Superb. Lindlar catalyst reaction is Rosenmund reduction, right? Very simple reaction. See how fortunate would we be if we are asked these questions. Spin only magnetic, looks to be today's questions are just a roller coaster, isn't it? Now spin only magnetic quantum number of the complex species which is given to us. In such cases, what you would see first is central metal ion. Is nothing but what? Ni plus 2. You will write the configuration of electronic configuration of Ni plus 2. You got the answer also. 0. अनिश, शायद ये सब गलती किया आपने पिछले साल. sp3 डिहाइब्रिडाइजेशन है, 4 लिगैंड है, डोरेमन. Doraemon. I am like, this is so funny to call someone Doraemon, isn't it, right? Chalo, let's see. All of you are mentioning B. Huh? That's you guys have corrected yourself. 0 कैसे होगा बेटे अमन? Let's check, right? Nickel in place 2 is what? Argon. That is 18 have gone, right? 3d8, 4s2, 4p0 and 4d0. This is the configuration of the Ni plus 2 what we have with us. And next we need to check that it is a weak field ligand. है ना? Weak field ligand. Brilliant, Aman. Thank you for helping me here. Weak field ligand में will there be pairing? Could you please help me with that? Will there be any pairing, buddy? Ni plus 2, right? 2 electrons we have removed. Will there be pairing, Aman? Pairing hoga? Come on, anybody else? Nandu, where are you? Varshini, ready? You're there, right? No pairing. So electrons would remain separate. So you have 5. All right. and look at the number of ligand that are present with it, like to in order to mention how many ligands are there. 4 ligands each carrying this thing. So hybridization is sp3 and the geometry is tetrahedral. Since number of odd electrons are 2, the spin only would be, alright, brilliant, excellent. Usha Sri, got it right. Chalo. You can see thermodynamics question. When we talk about the work done in a particular process, we should not be constrained to only P delta V thing. Listen to me now. We are sure about the relationship between delta H and delta U. Isn't it? We know the relationship because we know H equal to, let me write that first equation, H equal to U plus PV, or you can write it as U plus nRT. Alright. Now when we talk about what you call delta H, it becomes delta U plus delta of PV, or you can write it as delta U plus delta of nRT. Now when I take the difference of these two, delta H and delta U, you can see multiple ways this could be written. Delta H and delta U difference, listen to me first buddies, let me explain you certain more things related to this. How do we denote or notate the difference between delta H and delta U is very important. You guys can see here, I can write as delta of nRT, I can write as nR delta T, delta N of RT, delta of PV, P delta V, or V delta P. Anyways I can write depending upon the conditions which are specified to me, isn't it? Doraemon? Yeah, dancing queen. I think you applied while dancing, or you danced while applying. So, sir, in the application, my parents' name got interchanged. Will I be able to attend the exam? Yes, certainly. Why not? No, nothing, buddy. You have missed reading the comment. That's all. The point is, yes, you can attend the examination. That's not a problem, right? Is that clear? Can you hear me? Dancing queen. You can write the exam pretty much. There's no problem. Parents are parents even if you interchange their names, isn't it? Chalo. Now dance. It's a happy moment for you, isn't it? Right? Anyways, it's not your parent who are writing the examination, so nothing to worry, just chill, relax. Alright? Listen now what is happening. We are talking about the work done in various processes, isn't it? So delta H equal to delta U plus something, that plus something is the work done. Because you see, listen to me, in a closed container, just imagine a gas is present in a closed room. Whatever heat that I am supplying, whatever heat that I am supplying will be used to increase its internal energy. Kaam baam nahi karta wo. That is not doing any work, it is staying idle because room is closed, the society is closed. So when there is constant volume, all the heat that is supplied to the system is used to increase its internal energy. That is called delta U. Whereas at constant pressure, that means when I am opening the room and supplying the heat, it not only increases the internal energy but also does some work called as delta H. So the difference between delta H and delta U is actually work done. So I can represent the work done in multiple forms depending upon the data that is given to me. Remember this. That's very important, isn't it? Alright. So any formula can be used. Alright. Here which formula is given? Routine formula P delta V. This you can use in isobaric condition. That means when pressure is kept constant, isn't it, Aditya? Therefore, what do you use here? right? Looks to be simple, right? W equal to, yeah. There is another doubt, there is nothing as such anything present. You guys can see that it is expanding, all right. So PdV, sir, isothermal irreversible is given, no need to worry. When it is irreversible, pressure of the gas will be equal to the external pressure. That is the only thing that one has to understand. Don't get distracted by that irreversible thing. PdV only. If it is reversible, pressure of gas equal to external pressure. If it is irreversible, external pressure will be much greater. You can see that external pressure is given. So in that case, W equal to P into dV, all right, V2 minus V1. However, the sign would have been given negative sign because it is expanding 1 liter to 10 liter. Expansion work is negative in chemistry. So this is in atmosphere, this is in liter, answers are in calorie, all right. You have to convert that in calorie, all right. I understand, that's not a problem, I said, right? No, that's okay, that's not a problem. Who is going to check? After examination, when you go for the counseling, after successfully clearing it, you can rectify it. In the examination hall, they won't mind that, isn't it? Is it all right? Now, let us not worry about that. Are you understanding the basic logic here? Every examination center will have thousands of people. The examiners or invigilators doesn't have the time to check each and every admit card whether she had written the correct name or not. Actually, you were given edit option. You would have done that long back. But since the time had passed, now there is nothing we can do about it, isn't it? Now, other than writing for the exam, you have no other choice. So don't keep this at the back of your mind. When you go to the examination hall with this trauma, you will definitely fumble. Let me assure you this, let me reiterate this, nothing will happen to you, just concentrate on your preparation. Is that clear? All right, shall I move on? Yes. No, I am not just saying this because you have to feel good, that's true. All right, you need not worry. So when you simplify this, you will get your answer. You have to convert that in calorie. Sir, how can I convert that in calorie? Do I have to remember these values? No, bete, there is a technique. There is a technique to everything. Nothing to be remembered or memorized. Listen to me. You know R value, isn't it? 0.0821 in liter atmosphere. And you know calorie, R value in calorie. That's all. What you can do is, this is in liter atmosphere, no? That is 9. You can convert that into liter atmosphere into what? Calorie by substituting that value over here. 1 liter atmosphere is equal to what? 2 divided by 0.0821 calorie. This is how you can make the conversion happen by just remembering the value of R. Yes, आपने मदद कर दिया मेरा. Thank you, Anish. But I must tell them, how can they remember this value? Alright, now let's see this question which is based on the acidic strength. बहुत easy question, extremely easy and simple question was asked. Listen now, trifluoroacetic acid. More the electron withdrawing group, more is what you call acidic strength. We have studied many times, isn't it? More the electron withdrawing group, more is acidic strength. What's the answer? A. Very good, superb. Then you have formic acid. Formic acid is more than that of acetic acid. You guys have to remember this. Formic acid has more acidic strength because CH3 has plus psi. Electron releasing groups decreases. Yes, directly given in NCERT. The direct question, if you have watched, that's what I told you, NCERT will help you like anything. Brilliant. So you can see that the answer is A. Superb. Withdrawing group more, acidic strength is more. Yes, good. Chalo, next question. Easy. When you take an alkyne, when you are adding water, don't search for water in this reagent. You can see 1% of mercuric sulfate has 99% of water, but its percentage decreases when you add H2SO4. That means on the whole 31% of these two, 69% of water only. So need not search for it, it is not mentioned, but this always indicates that the water is added. Brilliant. Kya baat hai. So when you are adding water, water has to be regarded as H plus and OH minus Markovnikov addition. You know that this carbon with less hydrogen is added the nucleophile. You know you will be getting first the enol form, which is later on converted into the ketone. So what I got is acetone, which is treated with the Grignard reagent, very popular reaction, to give you tertiary alcohol. Simple, you would get 3 degree alcohol with ketone, 2 degree alcohol with any aldehyde, 1 degree alcohol with formaldehyde. Therefore, the right answer would be, someone said C here. How could it be? Acetone intermediate. Yes, B होगा. Brilliant. अमन बेटे A बोला तूने. Vitamin B1 मार रोज डांटती है. Isn't it? Beriberi, isn't it? Thiamine deficiency. What else you call it as? Thiamine deficiency, no? Beriberi. Direct question, no? Meta directing. How would you predict? Come on, tell me. Doraemon, could you please tell me how would you predict meta directing group? Come on, I'm waiting for your answers, buddy. C. Excellent. How could you say that? How? Usha? Yes, brilliant. Any group that has a lone pair shows plus M. Oxygen has a lone pair, nitrogen has a lone pair. Any group that shows plus M is ortho-para-directing, isn't it? Ortho, comma, para. Any group that doesn't have lone pair, however attached to the oxygen, it doesn't have any lone pair, it has donated the lone pair to the oxygen. Moreover, there is a pi bond unsaturation with the oxygen. Then in that case, you call it as minus M. And all those groups that show minus M are meta-directing. Good. Easy question, intermediate NCERT based 12th class question. Will be fortunate. Yes, it decreases the density, electron density. Kya baat hai? Yes. Anish is speaking in Telugu. Which one of the following is ionic? Come on, this truly test your merit, buddies. Come on. What's your answer, Aman? क्या बोलते हो? Waiting for your answers, buddies. What's the last answer? Come on, wind up. B. Whatever. Anish says B. Aman says Sai Vishwak. Everybody. D. You know, Sai Vishwak Rudra said D. Metal. ये कैसे हो गया अनिश? मेटल बोल दिया तूने. Bismuth is a metal. That means the BIF3 exception. ऐसे कैसे बेटा? No. This is something which is related to the Fajan rule, isn't it? Fajan. Huh? Ionic and covalent has to be essentially predicted by using the Fajan rule, which says that if the cation is smaller, what does it say? If the cation is smaller, it is more covalent. If anion is larger, it is more covalent. It's not an exception, buddy. Okay, so you guys can see here, everywhere you have taken a cation or anion. Fluorine is present, so it is present as negative. So all these are present. Fifth group elements are present as the cation. Now when we talk about the sizes, ionic radius, you know that nitrogen is smaller, bismuth is smallest. Oh, I wrote reverse. Oh, correct, only right. So bismuth is largest. You know that the smaller cation is more covalent. So covalent nature, when you predict, you know that n plus 3 is more. That means when you predict the ionic nature which is being spoken about in this particular question, which one is more? Whichever is bigger in size. So you guys can see that bismuth is not an exception. All right. That's another reason oxidation state is not possible. However, if it forms, it is possible with fluorine. Let me explain this to you, buddy, Anish. Yes, Ashlok Jha, 300 out of 300. Chemistry में तो कितने होते हैं 180. And congratulations to you all for doing brilliantly. And look at this question again. Do you have to mug up these values, or isn't it very simple? Isn't it? You guys can see that ionic radii of A plus B minus is nearly the same, and the atomic radius of A plus atomic radius is being asked, the size of, right, size of A would be greater than A plus, and B minus is greater than B, isn't it? That's it. All right. So A greater than, only one option which is scattering this. Next, number of possible isomers. Come on, I am pretty sure that you might commit a mistake here. That's okay. You're talking about the percentile, buddy. J लिख के आ गए क्या? Come on, Aditya Verma. What is the answer? What is the answer? Doraemon said B. That means it should be B. लिख लो. Aditya Verma also got the right answer. Fantastic. D and L. That's so brilliant. Yes, that's so brilliant. नहीं, facial meridian नहीं है यहाँ पे. That comes in MA3, B3, buddy. ज़्यादा पढ़ लिया तुमने. Now listen, what will happen here when you are writing or drawing the structure? You guys can see that you will be writing cis and trans, isn't it? You know that Cl, ethylene diamine suppressant. Now over here, you guys can see what is happening. That since this compound is having plane of symmetry, you can see that you can cut this molecule into two identical halves. This isomer, which is trans, is not having any chirality. It is achiral. It is not optically active. It is optically inactive. Good, brilliant. However, when you take its cis isomer, let me explain this for you, because we generally tend to ignore what you call the optical isomerism. When I write this cis, you know that these two are non-superimposable mirror images, isn't it? Alright, so one is T. I don't know which one is T. It's only experimentally can be predicted, isn't it? But two optical isomers and one geometrical. Total number of isomers are 3. Haru, you're very late, buddy. Aniline reacts with bromine in water to give a major product. What is that? Aniline. Huh? Aniline. Tell me, NH2 is very strongly activating. What will happen? Haru, come on. Late vachina latest answer cheppala beta. Speak out. Very activating, isn't it? When you are adding bromine in water, highly polar conditions. Remember this, highly polar conditions will lead to the high concentration of the bromine substituting all the 3 positions of NH2. This occurs in OH also. The same thing can be seen in OH also. However, if I carry out this reaction in less polar medium, bromine in CS2, you will get either ortho, para. But if you take in water or acetic acid, you must know that all three positions would be picric acid. Yes, something like that. All right. Okay. Now, which of the following complexes show linkage isomerism? Linkage isomerism can be seen in the complexes which are having ambidentate ligands. That means more than one donating center could present. You can see all these are having only normal ligands except the fact that you have nitrito and nitro. Good job. Oh, Murari, you said A for this question. Now you are right, buddy. Come on, next question answer. BaCO3 stoichiometry, ambidentate ligand, buddies. BaCO3 decomposes. Stoichiometry simple questions are only asked, even the calculation is not so difficult, buddy. First of all, you have to write the equation, balance it. After that, convert the mass into mole. Molar mass is not calculative, it is given already. Now, what is the question? Volume of CO2 obtained at STP, obviously. 1:1 is the mole ratio. You can see number of moles of CO2 obtained is same as the number of moles of barium carbonate. And at STP, number of moles are calculated as V divided by 22.4 liters. So, V is equal to 9.85 by 197.3 into 22.4 liter. Whatever it is, maybe option B. Yes, correct. In an atom, you can see this question is from structure of the atom. Simple question, right? Heisenberg uncertainty principle. Now we can see that with an accuracy of 0.05%, accuracy of 0.05%, that means there is a scope of error of 0.005%. Sorry, that means here uncertainty in what is that actually? You have to find out electron moving with a speed of 600, right? So delta V will be 0.005 by 100 times of 600 meter per second, and delta X is asked. So please be careful while substituting the values. I think you don't have any doubt related to this. Delta X into delta V, we know the formula, is equal to H value you need to substitute. You will be given all the values indeed. H by 4 pi into M. All the values you need to substitute and get your answer for delta X. You need to simplify the calculations. Alright, you have to do it by yourself. Oxidation state of chromium is +3. Look at these questions. Anish. Yes, you are right, Doraemon. Bolo beta. What's your doubt? Please go ahead. I'm here to answer. But before that, would you please answer this so that I can wind up the session? Bus. 2x plus 3 into -2 equal to 0. So, x is equal to +3. What is the oxidation state here? +6. Over here, +6. Here also, +6. Chromium pentoxide structure, you know, isn't it? Butterfly, in which there are 2 peroxy bonds. Hence, the oxidation state is +6 but not +10. It's a blue color liquid, isn't it? I think you know this. Could you please tell us, butterfly? Yes. Could you please tell me what's the doubt that you have? Bolo beta. Anyways, it was nice interacting with you all. So the right answer for this question should be option A. Anything else? No. 7 more days to go. Waiting. CRO linkage. What do you mean? Chalo. Anyways, please post your doubts in the comment section. We are there to address even after the session gets over. It was all Good to see you here. Wonderful session went on. Thank you all. Keep smiling. You will certainly become the doctors. Thank you.